Very good evening, guys. Today we are back with another exciting problem. Before I start with this problem, make sure you guys like, share, and subscribe to the channel. I'm seeing 70% to 90% of my viewers are only viewing this channel, and around 10% people are subscribing. It would be a very great opportunity if you guys could go and hit the subscribe button. Okay. Let's start with today's problem. The today's problem is the left view of a binary tree. So as you can see that this is a easy problem, and we have to print the left view of the binary tree. Okay. So say for example, we will be given a binary tree 10, which is divided into 20 and 30, and 20 is divided into 40 and 60. What our task is to print the elements which appear in the left side. The elements which appear in the left side is 10, 20, and 40. So say for example, you will say, why not 60? So because 60 is on the right subtree of 20, that's why we are not going to consider 60. Okay. So how we are going to solve this problem effectively, and how everything is going to be done. So I'll be writing the algo over here. Okay, and you guys have to follow this. Okay, so the first task of today is that we have to take we have to first make a function. Okay, so function, which what it is going to do, function to return the elements of the left view of binary tree. Okay, this is our first task. Okay, so with the help, where we are going to store, we are going to store it inside a list, or you can say a array list. Okay, after that, what our task is going to be, so we have to check that, okay, check if root is null, check if root is equals to null. Okay, so once this check is done, what we can go is we can traverse through it. Okay, so we will be storing the elements in a queue order. So we can store queue, we can make a queue. Okay, and we can say as new linked list in order to avoid repetition of elements and add it in a sorted manner. Okay, now our task is we will be doing a breadth first search. Okay, we'll be doing a breadth first search. So we will be doing a BFS. What else do we are going to do? So what we are going to do is we are going to add the root, add root to the queue, okay, and after that we are going to check level order traversal. So we'll be forming a level order traversal. Okay, and after that what we are going to do, add we are going to add the left child. So we can write like this, add left child. Okay, so this was the problem and the algorithm. So let us understand it better with the help of the code. Okay, so as you can see, I'll be just quickly resetting this code. Okay, so what you can see that we'll be given a function like this, array list save left view. Okay, we'll be giving a function known as array list left view. So what I'm going to store inside this is I can have an array list. Okay, I can have an array list of the type integer. Okay, and I can call it result equals to new array list. Okay, I will have a new array list. My first task, as I told, to check if the root is equals to null. Okay, then I'm going to return the result. Okay, once I'm done with that, I will be making a queue data structure. So I can call it as you can call it as QEVU. Okay, queue, and this data structure will contain the nodes of the node class. I can call it as queue equals to new linked list, as I will store it in the order of a linked list. Okay, so once that is done, I can call queue dot add. I can add my root element. Okay, once that is done, I'm going to traverse. So I can call it queue. Okay, queue. So queue dot is. Okay, and what I'm going to do is first I'm going to take the size. So I can say level size equals to queue dot size, the total number of elements present in this particular queue. Okay, now for what I'm going to do is, like, this signifies the number of nodes at my current level. Okay, after that I'm going to traverse equals to 0, I less than level size, and I plus plus. Okay, after that I can have a current node. So I can call it as current node equals to, I can remove the first element from the queue. So queue dot whole. Okay, and now the first node is the like what I can guess is once I'm removing the first node present in the queue is my left value. Okay, so I can have a check like this. If my I is equals to 0, okay, I will be adding in the linked list result dot add. Will be adding in the linked list current. I can call current node dot data, which is storing the current data. Okay. After that, I'm going to add the left, so I can write add left child to its left child first to ensure that the left view is captured. Okay. So what I can do is I can just have a check for this. Okay, so I can write if my current node dot left has some value, that means it is not equals to null. Okay, then I'll be adding q dot add current node dot left. Okay, once this is done, I'm going to add the right child. So if the current node dot right is having some values, that means I'm going to add q dot add current node dot right. Okay, so my while loop is completed. After that, I can return the result. So just remove the extra spaces. I can here add the left child. Okay, add the right child. What else do I add? I can say this as add root element. Okay, add current data element. So remove top element and check. Okay, so what I'm going to take is okay, so I can call this as base case. So compile. So let me submit this code. So we have successfully completed today's problem statement. And make sure you guys like, share, and subscribe to my channel. I've been solving this for 191 days and around 8 days left to reach the 200 days. So yeah, like, share, and subscribe to the channel, and let us grow even more stronger and hone our DSA skills. Thank you so much.